Hi guys. So today I'll be talking about some basic principles that actually help you to build better software. These principles are just simply the solid principles and the dry principles. I'll start with the dry principles. Actually, the word dry in dry principles simply stands for don't repeat yourself. A number of us will not be able to afford airplane tickets if they only get to fly once. If an airplane only gets to fly once in its life cycle, imagine how expensive the tickets would be. Even great innovators like Elon Musk has always had this idea of reusability regarding technology. Reusability helps with efficiency. That's where the dry principles come in, right? The word dry simply stands for don't repeat yourself. What it means is that if you notice any repetitive logic that you have in your code or any kind of component that you have to use in multiple areas, you just try as much as you can to abstract the logic and just invoke the logic everywhere you want. For instance, imagine that you had to rewrite all the necessary logic for all the hooks in React in every component that you have to build. This will not be scalable, right? So that is why the developers of React thought it wise that all the hooks should just be in a certain module, and then we could just abstract them and use them in any component as we want. Now, the next principle that I believe every developer out there should be aware of is the solid principle. The word solid actually stands for S, single responsibility principle. This principle simply states that a class, module, or function should have only one reason to do. It simply means that every class, module, or function should just do one thing. Now, a number of us, when we want to achieve a lot of things with a class, we tend to overload that class with multiple responsibilities, thus violating this single responsibility principle. Try as much as you can to understand that each function should be like a worker that is just assigned one simple task. Now, if you have to integrate lots of tasks, it's wise that you segregate those different tasks and allot them to different functions or modules. This way, in the long run, when you want to make modifications or upgrades, it will be much more easier to just go to those specific functions and modules. Now, the next one is O. O stands for open-close principle. This principle states that classes, modules, and functions should be open for extension and closed for modification. So how do you know if you've violated this principle? You can't extend the functionality of a class, module, or function by just adding more code without modifying the existing code. Then probably you are violating this principle. Each class, module, or function should be easily extendable by just adding more code and not just by modifying existing code. As the software requirements changes, and that means the kind of task that each class, module, or function tends to address changes, then we can talk about modifying the existing code. Now, the next principle, L simply stands for the Liskov principle. It states that child classes or subclasses must be substitutable for their parent classes or superclass. This simply means that if your child class should be able to inherit the methods of your parent class and also extend on it. Your child class could easily extend on the inherited objects and method from the parent class. But if your child class cannot replace your parent class, then probably you are violating this principle. The next one is I. I simply stands for interface segregation principle. It simply states that clients should not be forced to implement interfaces or methods that they do not use. It simply explains that as a software developer, you are meant to break down your code base into multiple interfaces. It should be broken down to smaller, specific subsets of codes. Your code base should be broken down into multiple interfaces and components. This way, it's easier to maintain and easier to scale. For instance, in React, it is advisable to have multiple components for handling multiple tasks. The last one, D, stands for dependency inversion principle. This principle states that high-level modules should not depend on low-level modules. Instead, they should both depend on abstraction. Also, abstraction should not depend on details, but details should depend on abstractions. Instead of writing your code base in such a way that your high-level modules are depending on your low-level modules, it's much more better to find out those the logic that your high-level module needs and the ones that your low-level module needs, and just abstract them, thus making them as pure as possible. So if currently now in your code base, for you to modify some basic things in your high-level code, you need to modify the low-level module, then you are definitely violating this principle. Now, the bottom line and the bedrock of all these principles is just simple separation of concerns. To be very honest, this cannot be overemphasized in software development. We need to separate our concerns as much as possible, because in separating our concerns, we make our code base easier, lightweight, and also make it much more reusable and highly efficient. Just as it's going to be so expensive if an airplane gets to only fly once in its lifetime, that's how expensive it will be if your code base doesn't reuse as much code as possible. Reusing your code not only makes it lightweight, it also makes it much more easier to maintain and also to add more functionalities to it. Alright, guys, I hope you've learned a lot about solid principles and dry principles. I'll see you in the next. A word is enough for the wise.